Hello everyone, my name is Fuhelji from Tangji University. It is my pleasure to report to you all about our research and some recent research reflections. Then, the number of my report this time is 202503131. The title of my presentation is A Multi-Layered Identification Framework for Psychiatric Audio Recording Balancing Clinical Utility and Privacy Protection. And participants throughout the study included, first and foremost, myself from Tangji University, as well as Professors Chun Mengxin and Chun Development from the Mental Health Center affiliated to Tangji University, and Professor Xiao Zudong from Tangji University School of Medicine. Let me introduce myself first. I myself am a doctoral student, Shanghai Research Institute for Intelligent Autonomous System, Tangji University. My own research has focused on the intersection of artificial intelligence and mental health, the convergence of disciplinary paradigms. They care about self-harm behaviors, public health, and resilience of field. So far, more than 10 papers have been published. So why did we conduct such a study? The first is that the rapid development of artificial intelligence has brought a trend worthy of our attention. Currently, in various industries, we are all doing our research and our work through artificial intelligence. On July 2nd, 2025, there are two very important articles that combine psychology and AI posted in Nature. It represents one or two trends in the current development of artificial intelligence, extremely small and extremely large. First, let's look at the article on the left. It's an article that represents the smallest. It uses the RNN network. This is one that we are all very familiar with in our research networks. But about human mental processes, we used to have a lot of assumptions, including, say, relying on Bayesian models to make assumptions about our computational models, and many more previous linear and nonlinear models. However, with the development and understanding of current models becoming more profound, we started discovering some of the previous models when they combine human computational processes. Turns out it doesn't fit very well. Then this article proves paradigm training and fitting of behavioral experiments through RNN networks. Then compare it with human reproductive neural processes. It will make you feel better. That is to say, our current artificial neural networks is somewhat more than some of the hypotheses we've made about neural networks in psychology and neuroscience research before. It will perform better for human computational psychology and computational mental processes. The second is one of our very large networks. For example, our very popular big language model now. The image on the right is from the Nature article. It has passed countless experiments because we have a lot of research in psychology. It uses some behavioral experiments to reflect some situations and changes of this person. So he took these people's reactions and changes in their situation in psychological experiments, all the data we need for our large language model and AQA pair. Then describe this person's experiment with Then he used such a dataset to train and fine-tune a very classical lambda model. It is also a better model in the current model than Bill trained into his own trick. A model like this, he found that this basic model was fine-tuned after being trained on a large amount of data. He was predicting the experiments and reactions of people we hadn't trained or even known. It works very well. Therefore, these two articles of Nature, it fully reflects the current field of psychology and psychiatry. Our artificial intelligence is an alternative to our current research paradigm because this is based on an alternative to this research paradigm. We think a lot about the past. It may have some new changes. For example, Chun Rencheng's team at Tsinghua University, they published an article is the processing of audio recordings. He first separated audio into audio features and text features because audio has two meanings at the same time. Then the audio and text features are used to train using large language models to process its text features. Then use our traditional deep learning model to process audio features. Then the results of the two are combined for fusion training. When it comes to judging whether a person has suicidal ideation, his prediction accuracy is not bad. The best one can reach around 0.74 due to the unique nature of psychiatry. In fact, the accuracy of 0.74 is already very good. Also, we can pay attention to many large models like now, including step audio to this large language model. It is a large language model based on multimodality. They are also increasingly focused on recognizing emotions and more features of audio throughout the training process. That is, in addition to turning on audio to text, in addition to recognizing the meaning of the text itself, people are also starting to pay more attention to audio recognition. We can see from this example of the technical report. When he received an audio article, and he would create a description and a portrait of the audio, a man. Young people, 22, 25 years old. His speech is very slowly. Then I thought about it. That is to say, for an audio, it involves an understanding of the semantics of emotion beyond the text itself. This is our psychiatric department. Doctors are doing outpatient clinics and diagnosis and treatment. In fact, a very important part, the doctor. In fact, in addition to listening to what the patient has to say, he will also pay more attention to the patient's expression at the moment. Is the patient's voice tired? Is it anxiety? Is it anger? Let's put it all together. Get to know such a patient. Therefore, with the development of AI big language models today, we in psychiatry need to understand how some of this recognition works. A recently published review, he also gave a description of the current processing of audio by large language models, mainly divided into two categories. A large class is first through ASR plus LLM plus TTS such a framework, that is, by recognizing audio as text, and then we use the language model to process the text. Then form new text. The new text is converted to audio output. Such a process, it actually loses information about speech itself very easily. The second part is that we put the audio directly into the speech. Then we input a large language model with multimode processing capabilities. This large language model generates audio directly. There are two main paths in our ordinary medical practice and hospital application. I will find that there are applications for both paths, but therefore, faced with the situation that both paths are present, what are some of the things that we should be doing to protect our audio, protect our privacy? What about protecting our information from destruction? Let's go through them one by one. First of all, and just recently, I have put the Chinese version of the news here. It's our top C mental health center. They are already building a very large database of clinical patients with depression and anxiety disorders. They collected the patient's medical record information separately, the recording of the patients throughout the clinic, and so on. And then we think, because psychiatric patients, he has a lot of self-information coming out during this process. This information about the self is often related to the privacy of the patient. We build such a data. What are we going to do with this data? And in making sure that such a database is published in a paper in scientific research, and we're going to share that in the process without revealing the patient's privacy. We have some very obvious areas that need to be addressed. First of all, it is necessary to remove some parts that can directly identify the patient information first. It is impossible for us to preserve the gender of the patient and then his home address, such obvious information. The second word is a lot of our documents. It contains some raw information, metadata. It's all to be like where, who recorded it. These are likely to remain in the file. The third is our entire text. It definitely needs to be deleted. Some of the text is clearly identifiable in an individual's medical records. And then our fourth insight is that we need to also remove some of the information that can indirectly identify the person, like the year of birth. When was that born? His gender, his race, then his medical records. He can't recognize you because there is a lot of information, but when enough information is accumulated, we can also identify this person. Then there's some background sound input. This is some information that we accidentally entered. It includes some of us, like nurses, when you interact with doctors, something about you or someone else that the nurse accidentally read behind your back. We all have to remove it. And it's even more important that we not only recognize our semantic information, our audio also needs to undergo certain processing because everyone's audio is also unique. How about that? Current semantics. Let's go through them one by one. The unique feature of semantics is that it can represent many meanings. Take our Swiss writer Wassa as an example. An article published by, this is a study from Shan. It does that by analyzing the text of one of Wasser's smaller works. He discovered the development of some of his mental health conditions. For example, through his direct analysis of the text, he summed up 3 periods of his mental health from 1903 to 1907. He is relatively healthy from 1915 to 1919. He had reached the middle stage of his disease. There are more and more signs of instability in his writing. It indicates that he began to suffer from mental health problems. During the period from 1928 to 1929, he was already in the early stages of his hospitalization. However, his writing text has also undergone some obvious changes from his words. You see a lot of new words and grammatical innovations emerging. This reflects a psychotic symptom. That is to say, our text, even if we write fiction, even if we write prose, but the writing style of some of our texts, he may have exposed some of our personal mental health conditions. And the second path is to use sound directly as a diagnostic method for a disease. And then there's an overview. It was published in a very good journal in 2023. He found that speech can be used directly as a sound marker, and the speech of this sound as a sound marker. He's speaking Danish, German, Chinese, Japanese, etc. In the case of Crosby, he is also consistent with testing. That is to say, no matter what language we use, our voice itself can be helpful in the diagnosis of the disease group. The other is the language we use to communicate on our smartphones. It is also possible. Here's a study that literally translates the words that we communicate with on our smartphones into text. And it was able to quickly find out if these teenagers were at risk of depression. That is to say, our voice can recognize whether we are likely to have depression from 2 angles. And some typical cases of information leakage include Zhou Hongyi of 360 Company in 2012. He was in an interview to the sound of keystrokes on a landline phone. This was accidentally broadcast by the news media. Then there's the sound of someone quickly pressing his button, match his phone number one by one, obtained his phone number. The second is our current smartphones or our shopping platform, and they often come back with all sorts of information after it is combined and matched. constructs a personal portrait of us. Realize the push of some accurate advertisements. Another typical victim is our writer. After all these years, I didn't expect his text to be able to be taken out and recognized, then define him personally. So based on these two paths and some reflections from our work experience, we believe that the deprivatization of psychiatric corpus requires a multi-level processing and processing. First of all, the first one is a simple process at the further education level. It's not simple for further studies. He needs to convert speech. That means it can't be our voice directly. But in the process of this transformation, he wanted to preserve the rhythm of his voice. We can achieve tonal modification of certain sounds, etc. But after this treatment did not change his mood. Doesn't change some of the information in his language that might be used for diagnosis, because if you change all that, then the sound is meaningless. The second is the semantic level. For example, the specific ones we mentioned about name, age, and location need to be replaced. Maybe in the form of a little bit of intelligent editing, but in this editing process, we must preserve the context of our semantics. Because of the context of the language, it cannot be modified. If the background is changed, his language also loses a certain meaning. The other is the processing of the original data layer. Our time must be normalized. Don't keep the process either the information environment of the device. Sound should also be filtered and so on. In all our cases in recording, he cannot carry out a single testing for safety and ethical review, because maybe from file 1, it gives away a little bit of information. File 2 leaks a little bit of information. The leak of documents 1 and 2, it doesn't constitute a very serious leak. But if the information leaked by file 1 and file 2 is combined, it could cause a very serious leak. So here are some simple examples. It can also be found in our subsequent articles. There are all some very classic methods. We can independently protect the privacy of our information and remove it. But our biggest suggestion here is that single information independence is not enough. We must combine multiple information frameworks and use them simultaneously to ensure the security of our medical information. At the same time, interdisciplinary collaboration is also our future. I was talking to a colleague this morning. He thought audio was not multi. He thinks audio is converted to text. Then all we provide is really semantic information, but that can't be right because of the audio, even without the semantics. In our normal communication, even the sound of his crying and the speed of his speech, even if he expresses it clearly. We all had access to enough information about him as psychiatrists. So collaboration across disciplines is really important. It requires the collaboration of various disciplines in psychology, medical, AI, and ethics. The second thing is that our technology has to go hand in hand. Psychology, AI for science, and science for AI are combined at the same time. Personally, I have also tried to integrate machine learning and current artificial intelligence methods into our scientific research. But we will find that in the process of integration, sometimes due to the limitations of the discipline, everyone has chosen the wrong indicator. I recently published a review article on the problem of over-reliance on correlation coefficients in the field of brain science. If you are interested, you can take a look. That is to say, as our different disciplines consider the integration of different disciplinary approaches, we must communicate more, judging the evaluation of the quality of the method by each discipline. That's really important. Okay, thank you very much. If you have any questions, you can email me. This is my mailbox.